Hello friends, in today's video we are going to see our next topic related to concurrency utilities. The next topic is the next object, synchronization objects are countdown latches and cyclic barriers. There may be situations when we will want to wait until something has been finished. Okay, so unless and until the event that has been already let to complete, you have to wait outside. To handle such type of situation, concurrent API, latest concurrent API provides countdown latches. What is countdown latch? It initially created with count of number of events that must occur before the latch is released. Okay, so that number of events that are already registered or already told to occur must occur before the latch or lock is released. Okay, each time that event is happen, the count is decremented, and count is 0 means the latch is open, lock is open, and now the thread can enter. Countdown latch has the one constructor countdown latch number. So how many number of events you want to occur, that number of events will be inside the bracket. Number specifies number of events that must occur. To wait on the latch, a wait method. Okay, so it has to wait, which has the two forms. First form is void await, throws interrupted exception. Okay, waits until countdown latch goes to 0, and await, long wait, and time unit T. Here long wait only is the only number of milliseconds or number of time unit, any unit provide number of that number of long value it will wait. Okay, and TU is the time unit object. Okay, object of the time unit enumeration. It returns false if the time limit is reached and true if the countdown reaches 0. Okay, to signal an event to start the countdown method is called. Okay, each call decrements the count by 1 and count by 1 on the invoking object. In the main method that we are going to see as an example, before I will show you this example first of all. So this is the example CDL demo. Okay, for that project CDL demo is created. This CDL demo, package CDL demo is created, and this is the class CDL demo. Okay, so here countdown latch object is created, initial count is 5. Okay, so it will be decremented like 5, 4, 3, 2, and 1. After that, this is started using the start method. It has to wait using the thread has to wait using the await method, and after it is done, after the countdown latch is finished, it will be displaying the string as done. So here thread is my thread that implements the runnable interface. Okay, and latch is initially initialized with the C as a countdown latch parameter. So what actually is doing here, it is waiting, counting down from 0 to 5. So 5 times countdown will be done. 5, 4, 3, 2, and 1. Every time it is printing the I. 1, 2, and 5, and 5. Printing I, decrementing. Printing I, decrementing. What is it is decrementing? It is decrementing the number provided. What is the number provided? 5. Okay, so it is decrementing up to the pi number of times, and after it is finished with, it will display done. So let us just run this example. First of all, it is displaying starting, then 0, 1, 2, 3, 4, and then done. Okay, so this is the example, very much simple example of countdown latch. You can go through this. You can take it down as an example, or you can take a screenshot or photo of this program so that you can try it at home. Okay, so we will move to the actual explanation in the PPT example. In the main method called latch called CDL, that object we have seen in the program, initial count of 5. Okay, then object of thread is created, my thread, new thread, gen of new thread. In the run method, we are calling for loop for 1 to 0 to 5. CDL as a passed as a parameter to the constructor of my threads, which implements the runnable interface, and stored in the latch instance variable. Okay, so latch is equal to what we have seen here. Latch is equal to C. Okay, so CDL is passed over here, countdown latch. So here is provided, latch is equal to C. This type of code we have written. Next, then main thread calls await on CDL so that it will wait, which causes main thread to pause until CDL count has been decremented 5 times. Okay, so main thread will not be executed unless and until decrementation is done. The run method loop is created from 0 to 5, iterate 5 times. With each iteration, countdown is called on latch, okay, which refers to CDL. Okay, that is the main variable. After 5th iteration, lock or latch is open, which allows the main thread to resume. Okay, countdown latch is a powerful synchronization object, second synchronization object of the semaphore, that is appropriate when thread must have to wait unless and until all the happening things are actually happened. Okay, all the awaiting process has been finished. Next is cyclic barrier. The third synchronization object is the cyclic barrier. So here we are going to see situation in the programming language. Which type of situation? Two or more threads must wait at a predefined execution point. Okay, until all the threads in the set have reached that point. Some execution point is going to happen, but unless and until that execution point is reached, 2 or more threads must wait. In the previous thing, countdown latch, what we have seen, some event must occur before the lock or latch is open. Here what we are going to see, in the programming situation where something some execution point must occur, and unless and until that execution point has occurred, the thread has to, 2 or more thread has to wait. To handle such a situation, concurrent API provided cyclic barrier. It enables you to define synchronization object that suspends until the specified number of threads has reached the barrier point. Okay. So if there are three threads, and one execution point is going to occur in the programming situation. So synchronization object will be suspended. That synchronization object or the shared resource that is going to be shared among all the threads, that will be suspended unless and until all the threads that are waiting on that the shared resource has been occurred at that execution point or reach that barrier point. Two constructors are provided: cyclic barrier, integer number of threads, and cyclic barrier, integer number of threads plus runnable action. First is specifying the number of threads that must reach the barrier execution content. The must case, number of threads must occur reach the barrier before execution content. And cyclic barrier, number of threads and action, specify the thread that will be executed when the barrier is. So which thread that will be executed when that is provided in the second constructor. So specifically here in the second case, we are giving the actual thread that will be executed when the barrier is reached. So how to create it? First, create a cyclic barrier object, like creating schema 4 object, countdown latch object. First of all, create a cyclic barrier object and provide number of threads that must wait. When each thread reaches that particular execution point or barrier point, have it call await on that object. This will pause execution of the thread until all of the other threads also called await. So all has to wait unless and until all the threads have occurred at that particular barrier point. And after all threads are combined together or reach together at that barrier point, then only that shared resource will be released. That object synchronization object that is suspended will be reduced. Once the specified number of threads has reached, execution will resume. Also, you have specified an action, then that particular thread is executed in the second case. Await has two forms. First, await with no parameters, throws interrupted exception and broken barrier exception. Waits until all the threads have reached at that particular barrier or execution point. And second, integer await, long wait, time unit, throws interrupted, barrier exception, timeout exception. Waits only for the number of period of time provided by wait and the time unit enumeration. Okay. So first of all, it waits until all the threads has come. Second, only wait for particular time. Okay. If that at that particular point, if one or none of the thread has come or reached at that particular barrier point, then the execution will resume. It will not wait after that particular time. Suppose it is expecting to be suppose there are 5 threads available and the cyclic barrier is waiting for suppose 10 minutes. It will wait. You are provided 10 minutes. So 10 in long format and time unit is minute you have provided. If in 10 minutes, if none of the threads are coming or reaching at that execution point, the execution will resume after 10 minutes. It will not wait after 10 minutes. Okay? It's as simple as that. Both forms return a value that indicates the order that the threads arrive at the barrier point. Okay? Order. Integer is the order that the threads arrive at the barrier point. The first thread returns a value that is equal to number of threads waited upon minus 1. first returns a value equal to number of threads weighted upon minus 1. And thread, that is second thread, returns 0. Now we will see the example of cyclic barrier. In this example, set of 3 threads has reached that barrier with weight until that 3 threads execution point reach. When that occurs, thread specified by bar action execute. So let us see this example in the program itself. Let us close this DDL demo. And I will start with the bar barrier demo. For that, package barrier demo is created as usual. Okay. So this is the program. Directly we are entering into the main. Cyclic barrier object has been created. Okay. After 3 threads has occurred, new bar action will be executed. So every time after starting cyclic barrier A, start, new thread, B start, C start. Now in the my thread, cyclic barrier object has been created, which is initialized with the cyclic barrier is equal to C. So here in the my thread, first is cyclic barrier, second is its name. First is cyclic barrier, which is CB. Second is name. Okay, sorry. This is the second is name, that is A. So cyclic barrier thread A, cyclic barrier thread B, cyclic barrier thread C. Then in the run method, first of all, name will be displayed. Then weight on that cyclic barrier is called. Okay, a weight is called. Broken barrier exception, interrupted exception has been handled. And what is the bar action that will be implemented after the execution point has been reached? Only the display message is provided, that is barrier reached. Okay. So now I will run this so that you will understand it properly. Starting A, B, C and barrier reached. Okay. So this is a very simple program. If I extend something extra over here, I will uncomment this. Okay. I add 3 more threads over here and I run it again. Okay. So for these 3 particular things, waiting for 3. After that, it is displaying barrier reached. Let us change this to 5. Now let us check the output. 1, 2, 3, 4, 5. If I make it 6, after all has been finished, it will make you display A, B, C, X, Y, Z. If it is 1, it will only display 1, that is A, and after that B, C, X, Y, Z. Okay. So after each and every thread, it is showing barrier reached. Okay, so you can go through this project, you can write it down. Okay. It will release waiting thread each time number of threads called a wait. Okay. If you change in main and x state, x, y, and z, three new threads at the end that we have seen right now, it will be having this different output. Starting ABC barrier reached and starting then XYZ barrier reached. Cyclic barrier offers a streamlined solution to what was previously a complicated problem. Okay, so this way we have seen today two synchronization objects. First is countdown latch and second is cyclic barrier. If you have not understood anything of this, please go back and revise. Enjoy the session, enjoy the program, go to the program, practice them at home. Okay, if you will understand theory very well, you can understand the practical also, and you can implement it by your own also. Okay, so meet you in the next session with next synchronization objects. Thank you so much.